Welcome. We will now learn about Amazon Relational Database Service, commonly referred to as Amazon RDS. Amazon RDS is a managed relational database service that provides 6 familiar database engines that you can choose from. These database engines are Amazon Aurora, MySQL, MariaDB, Oracle, Microsoft SQL Server, and PostgreSQL. Because RDS is fully managed, it handles routine database tasks such as provisioning, patching, backup, recovery, failure detection, and repair. The basic building block of RDS is the database, known as the DB instance. The DB instance is an isolated database environment that can contain multiple user-created databases. It can be accessed with the same tools and applications that you use with a standalone database instance. When you create a database instance, you specify its class, which determines the CPU, memory, and network capacity of the server that is provisioned. RDS supports 3 types of instance classes: standard, memory optimized, and burstable performance. You also specify the instance storage type. The instance storage is an Amazon EBS volume that is allocated to the DB instance. You determine the type, performance, and size of the EBS volume. With regards to storage, RDS provides 3 types listed here. Notice that 2 are based on solid-state drives, or SSDs. There's General Purpose SSD, which is also known as GP2, Provisioned IOPS SSD, which is also known as IO1, and Magnetic. Database instance classes and instance storage types differ in performance characteristics and price, which enables you to tailor your performance and cost to the needs of your database. Because it's a fully managed service, Amazon RDS automatically creates periodic backups of a database instance. The entire instance is backed up to a storage volume snapshot during a backup window you specify. You can also specify how long to retain the backup. The first snapshot of a database instance contains the full data. The subsequent snapshots are incremental, which contain only the data that changed since the most recent snapshot. You also have the ability to back up a database instance manually by creating a snapshot. For more information about working with backups, search for Amazon RDS Backup and Restore in the AWS online documentation. As you can see here, the AWS CLI allows you to create an RDS snapshot. Note that the command requires you to include the DB instance identifier and the DB snapshot identifier, which is also known as the name of the snapshot. When the command is successful, the response will include information that describes the snapshot, such as the snapshot identifier and the database engine. Now here is the AWS CLI command that is used to restore from a snapshot. When the command is successful, it will return a response that includes information about the snapshot, such as the database instance identifier and the status of the snapshot restore. Be aware that after you restore a DB instance, it will not automatically be a member of the same security group as the original DB instance. If you want the same functionality as the previous DB instance, you must add it to the original security group. Here's how to copy an RDS snapshot using an AWS CLI command. Note the optional flag of copy tags, which ensures that the new copy retains all the tags of the original. When the command is successful, it will return a response that includes information about the snapshot. The information includes the status of the snapshot, which will be shown as creating. Occasionally, you must delete RDS snapshots. To do this, use the AWS CLI command. Please note that there is no confirmation response when you delete snapshots. If the command is successful, it will return a response with information about the snapshot. This information includes the status, which will be deleted. One of the main features of Amazon RDS is that you can configure a database instance with high availability using a multi-AZ deployment. This configuration automatically generates a standby copy of the database instance in another availability zone within the same VPC. After RDS makes the initial full copy, transactions are synced to the standby copy. Running a database in a multi-AZ deployment can enhance availability during planned system maintenance. It can also help protect your database against database failure and disruptions to availability zones. The diagram illustrates an RDS database instance that is configured with high availability. The primary instance runs in availability zone 1, and it serves requests from applications that run in availability zones 1 and 2. The standby replica runs in availability zone 2, and it provides data redundancy. It is synced from the primary instance. If the primary database instance fails, Amazon RDS automatically brings the standby database instance online as a new primary instance. Requests from both applications are then directed to the new primary instance. The failover happens without needing to change the application code because the requesting applications reference the database by name using the Amazon RDS Domain Name System, or DNS, endpoint. The synchronous replication means that there is no data loss. There are several ways that you can increase the capacity of your Amazon RDS installation. First, you can increase the capacity of a database server by changing its instance class, which enables you to increase the CPU and memory that are available to that instance. Just remember, when you change the instance class, there will be some downtime. This is also known as scaling vertically. Secondly, you can modify the allocated storage in order to increase storage capacity without incurring downtime. The diagram illustrates another way to increase performance. By adding read replicas to increase the performance of read-heavy database workloads, you can scale out beyond the capacity of a single database instance. For more information about scaling or RDS storage types, search for scaling your Amazon RDS instance vertically and horizontally, or RDS storage, respectively, in the AWS online documentation. Thanks for watching. We'll see you in the next video.